So what's interesting is that a lot of times when you're learning about fiber bundles, then they just go to the definition and then just tell you, well, this is what a fiber bundle is, and usually they define it as a triplet or something. What's interesting about this one book from, sorry, I'm gonna pronounce his name all wrong, Sardonsky, is that he's talking about advanced differential geometry, and then he starts from a fiber manifold. And then so a fiber manifold is not going to have everything with a fiber bundle. What it will have is that, okay, you will have a projection from this y to x, and then so y and x are going to be manifolds, and y is usually in fiber bundle language is the total space, and then this is the base space, and then dimension x is, let's just say, is just going to be of n, in positive integer. And so this is a diagram that I find very useful for a fiber bundle. So say x is our manifold. Okay, so for instance, we talked at length about that example. So the thing about it is that, so this will be a manifold, and then so above each point of the manifold, above each point x, is a fiber. So hence the word fiber. Honestly, I don't know how they come up with this. And then so this fiber will be indexed by the point x, and then so call it yx. So you could just imagine a bunch of fibers all along this total space. The dimension of the fiber is going to be the dimension of the total space minus the base space. Yeah. And so the only other property that you need for a fiber manifold is that if and only if there exists local section S such that y equals xx. So all that just means is that, okay, so it needs to have a projection, but you also need to have what's called a local section. So for every y, there should be a local section S that brings x back to 1. So here's the thing, right? So this whole fiber is going to get projected by pi to go to x. Now the inverse is going to be, in general, a multi-valued beast. So the inverse, the image of the inverse, so this inverse is going to bring x back to this entire fiber. So it's multi-valued. So there's many points it could go to. So for each of these points y, there has to exist a section, an S, that brings this guy back to any of these points. And that's all you need for a fiber manifold.